theorems or postulates that you're going to use are these two. All right, the angle side angle and the angle angle side. Okay, so we're going to use this now in these two. Yeah, Athena? What's going on here? Oh yeah, I meant to show the other ones. Thanks, Athena. I'm in a hurry here. I meant to show this one up here. Thank you. Is that better? All right, so let's try a proof. I give you that angle C is congruent to angle B, and angle D is congruent to angle F. All right, so currently we have side, 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 side angle, side, hypotenuse leg, angle, side, angle, and angle, angle, side. Which one are we never going to have? Angle, side, side, right. Okay, that's one that's never going to be an option. All right, so I'm given two angles, which means I'm right away going to probably eliminate the first three, because if I'm given two angles, I'm going to want to find the side, because those are my two options. Does that make sense? So the question is, why am I giving you M as the midpoint? Right, midpoint splits a side into two equal lengths, correct? All right, so if we can show this, then, or if we can say that, then which theorem or postulate are we using? Are we using angle, side, angle, or angle, angle, side? Are we agreeable about that? Okay, so let's do our little proof. We've got our statement and our reasons, and we've got our given. Okay. And we're going to say that for step 2, dm, the length dm is equal to the length fm by the definition of a midpoint. And because we can say that they're equal in length, remember we're always looking for three congruency statements, correct? So that leads us to say then that those are congruent. Would you agree? So that means dm is congruent to fm by definition of congruence. All right, and so then our last statement would be that triangle BDM is congruent to triangle CFM by the angle, angle, side. How'd you do? Does that make sense? Oh, I gotta go back. Okay. WZ bisects angle XZW and angle XWY. So in other words, these two are going to be congruent, yes? Does that make sense? And these two are going to be congruent. Would you agree? I want to prove that the top triangle is congruent to the bottom. So between angle, angle, side, and angle, side, angle, which of those two do you think we're going to want to go for? You think we're going to go for which one? Angle, side, angle. Where's my side? ZW. Now, am I going to say ZW to ZW or ZW to WZ? ZW for the top to ZW, right? One angle to two angle on the top, one angle to two angle on the bottom means ZW goes to ZW. Does that make sense? Okay. So we know that we've got our givens. All right, and we know then that the measure of angle XZW is equal to the measure of angle YZW. And likewise, we can also say that the measure of angle XWZ is equal to the measure of angle YWZ. Does that make sense? What's my reasoning? Correct definition of an angle bisector. So then, because we can say that they're equal, what, Athena? Well, I never gave you any congruency statements. Did I? All I told you is that we have an angle bisector. And that allows us to say that those measures are equal, which allows us to say that they are congruent. Would you agree? So the next statement would say that angle XZW is congruent to angle YZW, and angle XWZ is congruent to angle YWZ. Okay, and that's just the definition of congruence. And then we can say ZW is congruent to ZW, and what is this going to be, reflexive or symmetric? And then we can say that the triangles are congruent by the angle, side angle. Now you need to tell me what the angle names are, the letters for your triangle. Okay, I just ran out of time because I know y'all are hungry. Okay. All right, say that, and I will see you tomorrow. Notice that I moved to test one day. I think so, yeah.